Hello and welcome to another episode of Boundary Philosophy of Science episodes. We will talk about whether science develops through progression. A common belief was that science develops through progression. It aligns with our own understanding of science, which is constantly proposing new theories that replaces the old ones. This strands of ideas is supported by logical positivism. Under logical positivism, science requires justification. This theory in details requires two parts, like Hampel's HD model and the IBE method. So Hampel's HD model is Hampel's hyper-deductivist model. One begins with a hypothesis, and from this hypothesis, predictions are deducted. If these predictions are correct, then it justifies the hypothesis. More predictions are correct, then the hypothesis is more correct. If predictions were false, then the hypothesis would be falsified. When a hypothesis is falsified, the IBE can be used to create a new hypothesis. IBE, inference to the best explanation, by its name, refers to choosing a hypothesis that best explains the observed data. Through comparing with empirical neutral evidence, we are able to judge and compare between hypotheses. Under this framework, science progresses in a linear line, where new and justified theories replace old incorrect ones. Later theories are believed to be better than the previous ones, having more justification. This leads to logical positivism not valuing the history of science highly, since science is constantly advancing, and newer theories are better than those in the past. Then those in the past had no importance. The importance is that the new theories passes through rounds of justification. Logical positivists makes two distinctions when making their argument. The first is the distinction between the context of discovery and the context of justification. The context of discovery is the process how one arrives at a certain scientific theory. It is a subjective, psychological process that is not restricted by rules. The context of justification is how one justifies a theory, which requires evidence and is an objective process. So an example here is calculus hexagonal structure. So Kaklu found that the benzene molecules has a hexagon structure. He arrived at the hypothesis that the benzene molecules through dreaming about a snake biting at its tail. This was later confirmed by experiment. To logical positivists, what matters is not how the hypothesis is arrived at, which in this case is through a dream, but the justification that accompanies it. The second distinction is between the theory and the observed facts. Theories are the hypothesis that passes through justifications. If it does not pass enough justification, it is still a hypothesis. Observed facts are the evidence data, the empirical evidence that is used to judge and support hypotheses. This distinction is necessary because logical positivists would believe that argument between rivaling theories can be solved in an objective way, that is, comparing theories with neutral facts. Without such a distinction, then the rationality and objectivity of science under logical positivism would be compromised. Kuhn proposed a distinct theory that disagrees with the idea that science develops through progression. Under his own understanding, science develops more like a paradigm shift. A paradigm is made up of two things: fundamental assumptions that everyone in the scientific community accepts, and samples of problems that have been solved by these assumptions. When sharing a paradigm, scientists would all agree on a bunch of things, such as how future research would be oriented, what methods would be used to solve different problems, and what the potential answers would be looking like. A paradigm is an entire system of science, consisting of shared assumptions, beliefs, and values that unite a whole scientific community. The job of an ordinary scientist in this scientific community is not to check or challenge the paradigm, but to solve minor puzzles while making little change to the paradigm itself. Scientists should accept the paradigm fully and conduct research within its limits. If they had results contradicting the paradigm, they would question their experiment rather than the paradigm. A paradigm lasts decades or even centuries. Science just kept refining it until anomalies are discovered, and as anomalies accumulates to a certain amount where everyone doubts the paradigm, then begins a period of revolutionary science when people search together for a new paradigm. All kinds of alternatives were proposed, and from all these new alternatives, a new paradigm will be formed. According to Kuhn, this is backed by the historical evidence from the shift from Ptolemaic to Copernican, or the shift from Newtonian to Einsteinian science. Paradigm shift require a sort of faith of a scientist. Reasons are part of why a scientist would want to trust a new paradigm, but it is not enough on its own to form a paradigm shift. In Kuhn's understanding, science is not a linear progression. For example, he noted that Einstein's theory of relativity is in some respect more similar to Aristotelian view of science rather than Newtonian physics. This would lead to Kuhn valuing the history of science more than logical positivists, since newer science is not of higher value than past scientific theories. Kuhn made two arguments supporting his own idea. He believed that competing paradigms are typically incommensurable with one another. When an existing paradigm is replaced by a new paradigm in a scientific revolution, scientists have to abandon the whole conceptual framework created previously. The proponents of different paradigms do not make full contact with other paradigms. To support the idea, Kuhn believes Newton and Einstein use different concepts of the same term, mass, in their own paradigm. The same is for other paradigm shifts. The same terms have different comprehensions. the incommensurability thesis is supposed to rebut that paradigm shifts are objective and to strengthen his non-cumulative view of the history of science. If the old and new paradigm are incommensurable, then there will be no right or wrong of scientific theory, or right theory replacing the wrong theory. He also claimed that the old and new paradigms were incompatible. This statement was some kind skeptical, for if two paradigms is truly incompatible, we would not have to choose between paradigms. That is, if two things are incommensurable, then they cannot be incompatible. Kuhn thus loosens his standards of incommensurability, acknowledging that moderate incommensurability, which allows partial translations between paradigms. His second argument is the theory-ladenness of data. He believes that there is no theory-neutral data. Analyses are all based on distinct perspectives that the scientists who collects the data have. Logical positivists believes in the existence of theory-neutral data which are used to compare between theories. Kuhn argued that this is only an illusion. Data are biased by the preliminary assumptions that were made. According to Kuhn, then there is no need for distinctions between observed facts and theory, since in his understanding there is no neutral fact. Observed facts are merely evidences and extensions that are used to support theories. This will lead to two consequences. Solving a dispute between competing paradigm would be difficult since we cannot refer to the data and facts, since they depend on what paradigm they accept. It would also threaten our understanding of objective truth. Despite all kinds of objections like these, Kuhn's theory of scientific progress provides a way to explain science as not developing through progression, but rather through paradigm shifts.